Hello friends, I welcome you all in our Engineer Office lecture series. Friends, I'm Swapnil sir, and in today's video we will solve a problem based on projection of straight line. So the problem statement is in front of you. The point P of a line PQ is in HP and 20 mm in front of VP. The top view of a line PQ makes 40 degree with XY while its plan measures 80 mm. Draw the projections if the true length of a line is 100 mm. Find the true inclinations made by the line. From this problem statement, we can write down a given data. Point P of a line PQ is in HP. Point P, end point of a PQ line, point P is in the HP and 20 mm in front of VP. In front means it is below the XY line. The top view of a line PQ makes 40 degrees. So top view of a line, that is plan length, is inclined with VP at 40 degree. So beta angle is given in this problem with XY. While its plan length distance is 80 mm. Draw the projections if the true length TL is 100 mm. Find the true inclinations made by the line. So for this problem, for any line problem, we required to draw the reference diagram. So this is a XY plane. So draw this diagram, freehand diagram. This is a reference diagram. So PQ is given, this is P dash, this is P, theta angle, phi angle. This is locus of P dash, this is locus of P, Q, Q dash. This is true length. Project this point. This is a Q1 dash, this is a Q2. Project and then rotate. Top view. Project, then rotate. This is Q dash, this is Q. Top view, front view, and top view. So this front view makes alpha angle with XY and top view makes beta angle with XY. Now you can see. So from this reference diagram, we can solve our problem. Now first draw a XY line. This is XY reference line. Mark point P. P is in the point P is in the HP. So we'll get this point is on XY. So this is a P dash and it's 20 mm in front of VP. So below P dash, we can mark a point P. This is a 20 mm. Now draw a locus line. Now you can see in this problem the locus of P dash and XY is same, and this is point P. So this point naming line is locus of P. Now here you can see here beta angle is given. So beta is 40 degree. So mark a 40 degree. Beta is 40 degree. So mark a 40 degree angle. So this is a 40 degree beta angle. Draw this angle line, the thin line. Now plan length is also given 80 mm. So on this top view, on this plan lane, we can mark a 80 mm distance. So take a rounder and measure 80 mm distance in compass. Mark a arc on this 80 mm. Mark a arc on this top view. Now you'll get it directly Q point here. This is a point Q. So from this, draw a locus line. Draw a locus line. Locus of Q. This angle is called as a beta angle, and this distance is a plan length. Also, true length of a line is given 100 mm. So we know the locus of Q dash, and on this Q dash we can mark a Q2 point, and PQ2 is a true length distance. And in this problem, true length is given 100 mm. So measure 100 mm distance in compass and mark a arc on a locus of Q. So we will get a Q2 point here. This is point Q2. This is distance is called as a true length distance, and it is 100 mm. Now you can see this data is given, and from this given data we can solve this problem up to this stage. After that, you can compare the reference diagram. Now we know that Q dash and Q, it is on a same vertical line. So we can draw a vertical line, projection line, which is passing through Q. Is passing through Q. So draw the vertical line, thin line. Now you can see we have the true length in a top view. So if you project Q2 up to locus of P dash, and then if you mark a arc, I'll get a Q dash point. So by using projection and rotation concept, we can find a Q dash point. So we have the true length in a top view. So project this Q2 up to locus of P dash. This xy is nothing but a locus of P dash. So you can see here, I'll get this point. This point is nothing but your Q2 dash point. And this P dash to Q2 dash distance is nothing but a elevation length distance. Now take this elevation length distance and P dash as the center. This is elevation length distance. From P dash, measure distance and mark a arc on this vertical line. So here I'll get a Q dash point. So if you join P dash and Q dash, we will get a front view. This is a front view. It is called as a elevation line. This angle is called as a alpha angle. Now we can draw a locus line which is passing through Q dash. This is a locus of Q dash. We have the true length distance. So we can find a Q1 dash point. Measure this 100 mm distance in compass. From P dash, mark a arc on a locus of Q dash. Here I'll get a Q1 dash point. If you join P dash and Q1 dash, we will get a true length in a front view. This true length makes theta angle. I'll show the dimensions and measure alpha, measure theta, phi, elevation length distance. So this is a 20 mm. Now answers. Measure theta angle, 5 degree angle, elevation length and alpha angle. You can see here theta is equal to 40 degree, phi is equal to 30 degree, alpha is equal to 49 degree, and elevation length is 85 mm. So that's the complete solution for this problem. Try to solve this problem. Thanks for watching this video.